Hi everyone and welcome back to a new Java Interview Questions Made Easy episode. Today we are going to tackle the singleton pattern. Discussions about singletons are very common in Java interviews. Also, when you talk about singleton, it seems like a very straightforward question, but in fact, implementing a singleton correctly under the given circumstances is not exactly as trivial as it may appear. So if you plan to go to an interview, it's a pretty good idea to understand this pattern in depth. And by the end of this episode, you'll understand what a singleton is, some aspects that you need to consider when designing a singleton in Java. We're going to see a couple of methods to implement this pattern. And we'll also, get practical and write some code to demonstrate some of the, things that are in this episode. So that being said, let's get started. At its core, the singleton is a design pattern that restricts the instantiation of a class to exactly one object. In other words, using the singleton, you cannot create multiple instances of your class. And you create a single instance and then you reuse that instance throughout your application. If you think about concrete examples, I would say that logging frameworks are good candidates for applying this pattern. The guys that design Hibernate. So when you have the Hibernate session factory, that is in fact a singleton object, because the creation of the Hibernate session factory is something that is pretty expensive. It keeps all the connection details, the connection pooling, the SQL dialects, and so on and so forth. So you would not want to create a Hibernate session factory each time you want to execute a select statement in your database. Caching is also a good candidate for applying this pattern. And when we think about a singleton, there is a general approach, to implement this pattern, regardless of the variant that you will need to implement. So the first thing that we'll need is basically a private constructor. And I think this is pretty self-explanatory. If you have a class with a public constructor, then you are free to create as many instances as you want, because you can call the constructor directly. So we need to hide the constructor from the user. That's why the constructor is private. The second thing that we'll need is a static instance of the same type as the class. This variable basically will contain the single instance of that class that we will then share across our app. And finally, we will need a method that allows us to access that single instance. And obviously, it will be a static method. Okay, now this is a general approach, but like I said before, there are many ways to design a singleton based on what you need. Some things to consider are, for example, lazy versus eager instantiation. If your class, if creating your class is very time consuming, is very heavy, it's a very heavy process, then you will have to think if you want to do this process, upfront when the application starts, or if you want to do that process when it is needed. Another thing that you will want to consider is thread safety. Will your application run in a single-threaded environment or in a multi-threaded environment? Because based on this answer, you'll have to make slight adjustments to your implementation. Okay, this is the theory, a very brief theory of the singleton pattern, but I think we will be better able to understand it if we go live and write some code. So let's do just that. We'll start with a simple Java console application. The first case that I want to implement is the eager singleton, because it's also the easiest one. So we create a new class, we'll call it eager singleton. Okay, and now remember the 3 steps. Okay, so we need a static member to hold our instance. It's going to be of type eager singleton, and we'll call it instance. And because we're talking about an eager implementation, we will also instantiate it. Okay, now we have to make the constructor private. Okay, and the constructor is private. This means that outside nobody will be able to call the constructor, but we can of course use it inside this class. And last but not least, we will have a get method. So it's going to be a public static, let's say, instance, and this method is going to return, an eager singleton, and here we return the instance variable that we set up here. So we have a private constructor, and this is the method that retrieve the instance. Okay, and now we can go to our main class and we can start to create some singletons. So we say eager singleton is called es1 from eager singleton 1. Okay, so eager singleton instance, and let's create another one, eager singleton instance. Okay, and now we can print, for example, eager singleton comparison. Okay, es1 equals es2. Okay, okay, maybe this is not exactly the best way to represent this. Okay, so we'll create a boolean are equal, okay, which is, and now we're going to append are equal here. We're going to run our code, and we should get a true. Okay, so eager singleton comparison true. These two objects are equal, so we have our first basic singleton implementation. It's an eager implementation because we already instantiate the class here. And now this is the most trivial singleton implementation that you can make. Okay, it's easy to write, just a couple of lines of code. It's thread safe because we allocate this member here, and this is a static member, so we get thread safety by default. But for example, if this process here is very heavy, if this process takes a lot of time, then the eager implementation style might not be enough. So now we might think about a lazy style, and you would use a lazy singleton each time the instantiation phase takes a lot of time, or maybe you don't even know if you'll need that instance. Maybe you create an instance and you never use it, and then all that effort was for nothing. So the lazy singleton implementation allows us to defer the instantiation until somebody actually needs it. Okay, so second approach, okay, we'll call it lazy singleton. Okay, so just as before, we have a private static member to hold our instance. Again, we'll call it instance. This time we do not instantiate it, okay, because we want to implement this lazily. Again, we have a private constructor, lazy singleton. Okay, and we have a public static method that returns an instance of this class, and we'll call it instance. Okay, and now this is where we implement the logic. So we can say something like, okay, if instance is null, then instance is new, we instantiate it here, and then we return the instance. So if the instance has not been initialized, we create it and then we return it. Actually, I don't have to put this here, it's not correct. We have to put this here. Okay, so if the instance was not created, we instantiate it, we return it, otherwise we just return it. Okay, so this would be a naive implementation of a lazy singleton. But if you look closely, there's a problem with this. Remember what I said, you also need to take into consideration thread safety, and in this case this is not thread safe. In the early singleton implementation, we get thread safety via the fact that we instantiate the static member directly, but here we do not. This method does not protect us if multiple threads decide they want the instance. Okay, So we need to kind of, protect ourselves against this. So one way to do it is just to mark this method as synchronized. And now we get thread safety, and we also have, deferred instantiation. Okay, so let's test our class. Let's see if this actually works. I'm going to rename this r equal, okay. And now I'm going to create lazy singleton 1. Okay, as you can see, the usage is basically the same. It's just the implementation that is different. ls2 lazy singleton instance, and now a boolean variable lazy implementation equal, this is ls1 ls2. Okay, and we're going to duplicate this line, and lazy singleton comparison, and this is also a typo. Okay, we're going to change it. Okay, let's run our program, and this should also be, true. Okay, this implementation works just fine, but because you used synchronized at the method level, we will have a small performance hit. Now, is there any way that we can improve the performance of this instance method? And the answer is yes. We can go and refine this method to gain a performance boost with something that is called double lock checking. So we can create a new class here. We'll call it lazy fast singleton, and it's pretty much the same thing. We have an instance variable, we have a private constructor, and now we have our public static method. Okay, and we will not mark this method as synchronized. We will do the first check here. So we say if instance is null. Okay, this is the first check. And now we use synchronized here, and we'll synchronized, okay, on this object. And now we do a double check here as well. So if instance is null, then we instantiate it. Okay, so lazy fast singleton, and at the end we return the instance. Okay, and this is the second check. Okay, and this approach, gives us the performance boost. We do have two checks for null. The synchronized is only applied if the instance is null in the first place, so it will not be on the method level. But if you're using an older version of Java prior to version 1.5, then this will not give you the correct results. I mean, you're not guaranteed to receive the correct results. Because of the Java memory module, and because of the optimization the compiler does for us, we are not guaranteed to obtain a singleton instance in this manner each time. It depends on lots of factors. After Java 1.5, this problem has been fixed if you mark the static variable here with the volatile keyword. Okay, and volatile basically means that, okay, each time this field is modified, all the threads in your application are notified of the new value, so they are aware of that value change. And then this method is correct, but only if you have Java 1.5 or above. If not, then I suggest that you stick with the lazy singleton implementation that we have discussed here. But it's also okay to know this one in case you're interested in the performance boost and in case you're working with the current versions of Java. Now I want to show you something really cool. Okay, so I'm in my main method, and I'll do something like this here. I'll say, constructor, say, okay, this is eager singleton class get declared constructor, and I can say, I think it's like new class, something like this. We add the exception to the method signature, and I can set the accessibility of this constructor to true. And now I can say eager singleton free is now eager singleton constructor, and I call the new instance method on the constructor. We add these exceptions. Okay, so I managed to obtain an instance of eager singleton by using reflection. Okay, so let's see what's happening when I'm trying to compare this instance with one of these. Okay, so I'm going to have a boolean flag, our reflection equal, and this is es1 es3. So I'm comparing the first singleton obtained with the instance method with the singleton that I just created here using reflection. And I'm going to override this. Okay, our reflection equal, and now let's run our code and see what's happening. Okay, so reflection comparison is false. That means that I managed to obtain a new instance of this class, even though I have a private constructor, I have a private static instance, I'm using eager loading, this is thread safe. So it appears that there is somehow a way using reflection to actually bypass the singleton pattern. Now the question is there any way to implement this pattern and also get protection from, you know, these kinds of I wouldn't call them exploits, but this is definitely something that you can do to, you know, bypass things that have been declared. And luckily for us, the answer is yes. And believe it or not, you can implement a singleton in Java using an enum. Yep, that's right, a plain old enum. So I can say enum singleton. Okay, it's an enum. Okay, and it's an enum with a single member instance, which will return this one. And because, you know, we have instances and enums in Java, you know, behave like a class with some limitations, we get the same functionality as you would from a class. So it's definitely possible, you know, to have methods in here. You know, you can have a public void, you know, do stuff here. I mean, nobody's stopping you from doing it. Okay, and you can actually have a class-like behavior in this one, and with this approach we actually have a singleton. And believe it or not, this is the most elegant, most easy, and the safest implementation that you can have for a singleton design pattern. And I've actually read this one in a book called Effective Java by Joshua Block. If you haven't read it, then it's highly recommended. It's a must read for anyone who wants to be, you know, a professional Java developer. And I'll put you the link in the description of this video below. And now we cannot do reflection, you know, to create multiple instances. We have thread safety, and it's pretty easy to write. Of course, this is an eager implementation, so we cannot, you know, speed things up or delegate the instantiation to a later phase. But, you know, just to prove that it works, I can say enum singleton, call it S1, and this is enum singleton instance, pretty easy. And now I have enum singleton S2, and this is enum singleton instance again, and we have a boolean flag, enum singleton equal, this is S1 equal S2. And now we can also duplicate this line, and okay, and we can run our program, and we should get it true here, and there it is, true. Okay, so at this point in time we've covered 4 ways to create a singleton. The one that I would recommend is this one. It's the easiest to write, it's thread safe, you cannot use reflection on it, so use this one with confidence. It's going to do wonders. I admit it's a little strange, but it's a pretty cool thing if you understand how it works. Okay, now that we've seen 4 implementations, I just want to give you one last word of caution when using singletons. The first one is don't overuse them, okay? Because by nature, singletons, they contain a lot of statics, and this makes them extremely difficult, if not impossible, to test. So unless something really needs to be a singleton, then don't abuse this design pattern. Also, I don't know, if you're developing web applications and you have Spring or some form of dependency injection mechanism in your app, then you can just create simple Pojo classes, and then use the dependency injector to assure that that object is a singleton. And in Spring, for example, you can achieve this by using the scope annotation on a bean. By default, beans are singleton in scope, and thus you get a singleton from the CDI, but at the same time you don't have to do all this ceremony, and you don't have to use static fields in your classes, which makes them testable. So this is something that you should also consider when developing production ready applications. Okay guys, thank you very much. You can find the source code on GitHub. You'll see the description in the link below. If you enjoyed this video, please click the like button and don't forget to share it with your friends. You can also find me on Twitter as Romanian Coder, and if you want to read more articles on software development, you can also check out my blog www.romaniancoder.com. Until the next episode, have a great day and write amazing code. Goodbye.